So thanks again, yeah, for showing up. I really appreciate it. And this is for you guys. We want to answer all the questions that you have about drip. I've been doing drip for, well, I've been doing irrigation efficiency for about 10 years. I've been, like Nicole said, I've been in the industry for over 20, like 23, 24 years. And when I found irrigation, it was through irrigation management. That's how I really started to understand irrigation. And as soon as I got that understanding of irrigation, it really became my main goal is water conservation. I just saw how much waste was happening in the landscape. And so it's really very important to me to do whatever I can to educate, to install, to keep learning about irrigation efficiency and water management. So I just this year have started the new company, Water Service, which again is all about irrigation efficiency. And it's great. It's keeping us real busy. And as the attendance shows, people are very interested. So thanks again. And I'm going to just talk a little bit about what we're going to be covering today. First of all, we're going to be going over components, the layout of those components, and the soil-water relationship. That's a big part of irrigation and efficiency. And we'll touch on some scheduling and then some hydraulic aspects of irrigation as well. So we're going to really just kind of start with components, which I have a few out here. There's so many types of different drip components and ways to go about creating a drip system. My focus is going to be inline drip emitter tubing, and pretty specifically to the 1/2-inch inline emitter drip tubing. So this is just a little section of it, and I'm going to pull this up. I'll be moving around a little bit. You can see there it is. There's the emitter within the tubing. So where we have inline emitter tubing, which I just showed you, this is probably what a lot of people are used to seeing as far as a drip system is concerned. You have the blank poly tubing, and then you poke a hole with your little tool, and you get these tiny little couplers in, and you get this 1/4-inch line to your plants. And then you put your emitter on that. So that's really kind of dated as far as I'm concerned, because this is just one little emitter, and we're going to get into that a little bit more, a lot more really. So basic components, this is called point source. The inline emitter tubing is called line source. And the basic, the general, I would say the most important thing about the inline emitter tubing is that you can lay it out in a grid. So without seeing all the little holes, they are here. Every 12 inches on this one. The one I showed you first was every 18 inches. So if you can imagine this, you got your plants here, you have water going all around that root zone. And that's really important for the long-term health of the plant and to get a plant established. Whereas the point source that I was just showing you, that's going to get that plant established, get it through the first year, maybe 2, but then you're going to start to see a lacking of this system because it's not really encompassing that whole root zone, that whole root area. So that's one component or 2 components of drip. You know, I'm sure people are familiar with this type of device as well, quadra-bubbler or octa-bubbler. And here we have a quadra-bubbler. And if anybody is familiar with these, I'm sure you know how frustrating they can be and how they break down and they don't really do a great job maintenance-wise. They're a lot to deal with. This technology, I wouldn't even call it technology. These little devices were built, they were developed in the 70s in California because of the drought that was going on. And it was really they were made to just kind of replace a spray head on a riser. And so they're really cheap. They're really, they're not very durable. So I do not recommend quadribubblers, octobubblers, that type of thing. And then you have a couple more components that people call drip, and that would be a Shrubbler. So this would, again, come off of that 1/2-inch poly tubing from the 1/4 inch, and then this would go to your plant, and it goes out in a spray pattern. Not a spray pattern, but all these little holes let water out. So not really a drip, right? We have streams coming out all over this. So it's not a very slow application of the water. And then you have a micro spray. And this is, again, pretty common. If you are going to use the micro sprays, and there's very few instances that I would definitely go for the adjustable ones. You can see there's a little knob right here that you could control the throw. So you could bring it down a little bit, so you're not, say, spraying over onto a sidewalk or out of the bed or out of the area that you're trying to water. So those are a few things. Other drip components, those are the basic kind of ways that you would use a drip system. And again, we're going to be focusing on the 1/2-inch inline emitter tubing. And the reason why we're doing that is water conservation. Water conservation through irrigation efficiency. So instead of just kind of throwing the parts out there and getting water to the plants without really thinking about it, we are able to measure the water. If you take one of these, the quadra bubbler, there's no real regulation. You can't really be sure how much water's coming out of each emitter because there's no pressure compensation, and it can change. So even if they say it's a 1/2 gallon, say with one of these little emitters, even if they say it's a 1/2 gallon, it may be more than that if it's at the beginning of the line, and it may be less than that if it's at the end of the line. So pressure has a lot to do with irrigation as well. But along the conservation, what we're trying to do is use water in the most efficient way possible. So if you go with a pop-up head, a traditional way to, say, water a lawn area, the head pops up, it sprays out and covers the area, and you got sprinklers all over within an area. If you're using the typical fixed spray where the water is just being sprayed out, it is coming out at such a high rate that it is essentially the soil's not able to absorb it properly or at the same rate. So just as an example, if you're looking at like a typical lawn situation, more in that older style with those fan sprays that are coming out and spraying water everywhere, your precipitation rate, how much water's coming out, how much water's falling in one area, is going to be 1.8 inches per hour, essentially. That's give or take. There's different components and they all have slightly different numbers, but you're really looking at a high rate, a high application rate. You're really throwing the water out and just kind of leaving it to its own devices and hoping that you get what you need out of it. If you go into the 1/2-inch drip emitter tubing type style, you have a range of precipitation rates due to how you lay it all out, which we'll go into later as well. But you're really looking at, again, 1.8 inches an hour for an old style type spray system. And when you go into this style here with the inline emitter tubing, you're really looking at, you can go down to 0.2 inches an hour, but where we irrigate is between, I would say most likely between 0.4 and 1 inch per hour. So you can see that already we're really bringing those numbers down. So really what we're doing is slowing the water down. So instead of spraying it out and just throwing it everywhere. We're actually just slowing it down. We're bringing it down to a level where the soil can manage it better. Another inherent property of drip irrigation as opposed to an overhead spray is that it has no misting. So if everybody has seen that when the sprinklers are on, there's water going up into the air. It's ionization. It's because it's being pushed out at such a high pressure and such a fast rate that it's just going up into the air. That's called misting. And so that's water loss. It's water you're seeing do that. It's not going onto the ground. It's going away and into the air. So who knows where it's going. Another component of those old type style sprays are going to be overspray. You're going to have misting. You're going to have overspray in a lot of those situations. So that is when the water is being sprayed onto the sidewalk or outside of the area that you're trying to water, onto the driveway. So it's really not, it's all wasted water. Really, when you look at it from a water use perspective, it's wasted water. We have a huge reduction in runoff, if not zero runoff with the drip system. If you're managing it properly, you're not going to have runoff. And what runoff is again, it's that slowing the water down. So if you're applying water at a very high, a very fast rate, then the soil's not going to absorb it too good, and that's called runoff. Now, runoff doesn't necessarily mean that you see it running away on top of the soil. It's not always the case. Runoff can also be going down. If soil can't absorb it fully, there's still spaces in the soil where the water can move through. And say you have a root zone of a foot that you're trying to hit, and you're putting the water down at such a high rate that the water's going well below that, then you're actually you're wasting that water that goes below your target root zone. So that's another benefit of drip, is that you're slowing it down so it actually just goes right where you want it to with proper scheduling. So we got runoff, essentially too, evaporation. So I mentioned the misting, which is ionization. If you're spraying, if you're overhead spraying an area, there's water that's going to be either on the mulch or directly on the ground or on the plants. That is going to evaporate, and that's going to, again, it's just wasted water. So with a drip system that you put right on top of the soil and then bury it with, say, 2 to 3 inches of mulch, you're not going to have evaporation. So inherently, just by switching from a spray to a drip system, you're going to be using the water in a much more efficient way. So we're getting rid of misting, overspray, runoff, and also evaporation. So we have 4 points right off the bat where we're saving water. And we're also slowing the water down. So that really is the application rate, the rate at which we're applying the water. So really good things to think about. Another benefit to especially the grid system of this stuff, is that you're putting the water right where the plants need it, right into the root zone, right at the soil level. So again, not overhead application. So that's an overview, kind of a reasoning why we're doing this. So we're going to have another section here, which I'm going to go over the really important components of a drip system, and then we can start taking some questions. So the number one component that you have to have in every single drip system is going to be a filter and a pressure regulator. So here's the valve, and most systems have valves, but not all do. But what all systems have to have, all drip systems, is this filter and a pressure regulator. So this one here is all one unit. This filter and pressure regulator, that's all one piece. They also come, and everybody, all the different companies have their own. This is also a filter and pressure reducer combo. It's a lot smaller And you can see here, there we go. It's a lot smaller than this one. And this is a Hunter brand. This is a Rainbird. Everybody's got their own. There's generic brands out there, and a ton of different drip companies, you know, that do this type of thing. This one here is separate. So the filter and the pressure reducer are separate. You can see I can move those apart from each other. The valve, this is an inline valve. The one I showed you before is an anti-siphon valve. But again, number one component in any drip system is going to be the filter and the pressure regulator. And you know, you can come off of a hose bib if you wanted to and just control it yourself and put a filter and a pressure reducer in that and convert to your drip system and be just fine. The valves are, of course, for an automated system, and that just makes your life a little easier a lot of times, not always. Yeah, so we kind of already went over the types of emitters. Now, I'm going to get back up here again. I'm going to go over some of the importance of these inline emitters. You can see that, again, we got the emitters inside the tubing. And I'm going to actually show you. I pre-cut this. So this is one of the emitters, right? And I cut it in half. And this is going to show you the technology, the design that's in one of those emitters inside that tubing. And it's pretty clear. You can see there's a little diaphragm in there, that white part, and then all these little channels. And it has to, the water has to move through all those little channels. And here's the hole. That's the hole. So expanded version. There's a lot going on in that little, inside that tubing. Now, there's just no way you can fit all of that technology into this tiny little piece. And these definitely don't have it. So we're going to stop talking about these. We're going to talk about the point source and the inline now for a minute. So point source, again, we can go straight to a plant's roots with this and get it established very nicely and confidently. But then we're lacking. If we have a point source, I'm going to throw up some plants here. So we have our plants. Okay. Very nice shrubs. And I'm going to give you an example of that point source. So kind of what most people are going to be used to, poly tubing with the emitter on the end there. So you have your valve and your filter and your pressure regulator, of course, and then that goes into the ground, and then your blank tubing runs through the planted area, okay? And then off of that, this 1/2 inch blank tubing, you poke holes into it, and then you take your 1/4 inch and you put that drip emitter right at the base of the plant, right? So great. You got that thing growing. You know, these plants are going to be happy for a year or so, again, like I said. But once they start throwing their roots out, once they start growing into their space, right? Here's their roots. What's this water doing? You know, we're really still just kind of focused on the center of the plant. So what we really would want to do if we're going to take this approach is add more of these emitters over here and over here and over here. So you can see it starts to get a little bit convoluted if you want this type of system to grow into your landscape. So that's one example. I'm going to leave my beautiful valve in place. I could draw more plants. Put these out again. Okay, now for our inline emitter tubing, we would get this blank line to wherever the plants start and then build a little header and run our drip tubing that have all those little emitters every 12 inches, every 18 inches, whatever is called for. on both sides of the plant. This is representing the mature size of the plant. So now, as you can see, if we start drawing out these roots again, we have pretty full coverage. We have little emitters everywhere. And the wetting patterns of those spread out. So you have a really nice, nice distribution of the water this way. And then at the end here, we have a little clean out. That's another component of any drip system. You're gonna want to have this water source be able to move through the whole system and then flush out the end. So that's a way, maintenance, a way of doing maintenance that keeps your system running smoothly. And I will bring up a couple of these flush components. So at the very end of your system, you want to be able to flush it. So here's a great one. At this point, I use these as a little auxiliary. If I have to put more than one clean out for whatever reason, this is my kind of secondary solution, but it's a ball valve. So you put this in a little box at the end of your station, and that's off and that's on. So you want to flush everything out, give that a minute or two once you've installed it, and then also every few months or once a year, just flush it all out, make sure everything's staying clean and running smoothly. So that's one way. This is a pretty solid and good way to do that. It's a little 1/2-inch barbed ball valve. Another cheaper and pretty easy way is a little figure 8. And what this does is you just slide that onto the tubing at the end, and you, here we go, fold it over and slide it back onto itself, and then you have a stopped point. So to flush it, you open and release that, and then the water runs through it and flushes, and then you fold it back over. So that's another way. My preferred way, which is really much more robust, is going to be this flexible Cobra tube, along with another ball valve, but it's a much more stout ball valve, and as you can see, it's threaded. And so especially when building bigger zones, this threaded piece allows you to put a pressure gauge on there and get a pressure reading. So really cool little tool here that goes in the box as well. And you take this out and flush it. You're able to direct the water wherever you want it to go. Say this one, if it's in a box, then you're just going to open it up, leave it in the box. The box floods with water. There's no problem with that. And then you reach down and close it, and then it stops flowing. So cleanouts are very important for all drip systems. And we have the importance of, so really what we're looking at between the point source, these little emitters, and the line source. Now, there's some key features that go along with our efficiency viewpoint and why we use this stuff here. This has one of them built in. These little emitters they are pressure compensating now. Most of these are pressure compensating. And what that means is that within a full system, so again, we're going to run this line. Here are multiple 1/4-inch lines coming off of that with those little point source emitters, right? So say we're starting at 40 PSI here at the beginning where they're coming from our valve. And then, we lose pressure as it moves through the pipe, and as water is released through the emitters, the pressure is reduced by a bit. 40 PSI is a pretty good starting point. I like to start with a lot of pressure, or as much pressure as I need, and to keep me in a safe zone. And 40 PSI is my little sweet spot. But as you can imagine, as you're losing pressure through the system, if they are not pressure compensating, then you'll have more water coming out of emitters that are in the beginning of the system than are at the latter part of the system. And so if they're pressure compensating emitters, you have a pretty regulated, it's going to be the same amount of water coming out of each of those emitters. So very important to know that you have pressure compensating emitters. Not all point source emitters are pressure compensating. Most of them are these days, but not all of them are. Now, moving on to the 1/2-inch inline emitter tubing. These are pressure compensating. So again, beginning of the zone and end of the zone, all these emitters are going to be putting out the same amount of water if it's designed and installed properly, of course. So very important, consistency, uniform distribution, that type of thing. We call it distribution uniformity. So this definitely matches that. You're going to have an equal amount of water coming out of each of these emitters, so you're going to have an even distribution of that water. The added features to the 1/2-inch inline emitter tubing stuff are that there's a couple. Well, one, there's a check valve built into it. Each of these little emitters in there. And if you remember when I showed you this here, okay, that kind of the white, it looks white probably, but it's kind of a clear plastic. That's a check valve. It's also the component that equalizes that pressure so that it is pressure compensating. But as a check valve, that's the key to even more water savings. A check valve, what that does is, so when the valve's on, all the emitters are putting out the same amount of water because of pressure compensation. And then when the valve turns off, there's a check valve. So when the pressure drops below 15 psi in one of these systems here, that little diaphragm closes. So no water is released from this anymore. And what that also does, so it's a check valve. And let me reference the point source again, these little guys, they do not have check valves built into them. They're pressure compensating, but no check valve. So say you're on a slope, right? You have a hillside here that you're kind of terraced and you're watering, and you have your tubing coming down, and you have all these little things coming off with the point source emitters, right? So as you drop in this elevation, or even if it's a slight slope, right? Even if you have just a slight slope, this is going to create the pressure because water's heavy, you know, it moves with gravity. These little emitters, these little point source emitters are going to keep letting water out because there's nothing holding it back. So a check valve in the inline emitter tubing is going to hold that water back. And in doing so, it acts, you can't really call it an anti-siphon, but when that check valve engages, this outer part where the hole is, where you see the hole in the tubing, it actually flushes itself. So when that water shuts off and holds it all in the line, this little bit flushes out. So it actually helps keep roots out. It's a little, it doesn't clog. So that check valve kind of keeps everything clean as well. It acts as an anti-siphon device, even though it's not an anti-siphon device. There we might have some questions on, and feel free, we are just about there. So the other piece of drip irrigation that I want to show you and talk to you about today is the 1/4-inch inline emitter tubing. So while it's inline and it looks very similar to the 1/2-inch tubing, right? This doesn't have any of those added benefits. It doesn't even have pressure compensation. The point source do, the 1/2-inch inline does, but these little 1/4-inch lines with emitters built into them, 1/4-inch inline emitter tubing. There's really nothing special about them other than they're very consistently placed, and the only time I use this stuff is for containers. Generally, you're not going to be on an elevation change if you have containers, and generally you're not going to have a huge zone, so pressure compensation and the check valve really don't mean as much. They're not as important. So that's another component to drip irrigation. Some people put this into vegetable beds. I would still go with the 1/2-inch inline for vegetable beds, and we'll get into that later as well. So fittings, you got to use the right fitting. You got to use the right fitting, and I see this all the time in my work that that people don't use the right fitting. So, for instance, you have the black poly tubing that most people are going to be pretty familiar with, and you have their types of fitting. It's a compression fitting, so this goes inside the fitting, okay? And it's specifically made for this size of pipe. Now you might see this. I know I do. This is a barbed fitting that's meant for the 1/2-inch inline emitter tubing. This is what you want to use here. It's a barbed fitting that goes inside the pipe. And you will see people using this type of fitting on this type of tubing. And they're both 1/2-inch. Okay, why can't we use it? Well, this is 18mm 1/2-inch tubing, and this is 17mm 1/2-inch tubing. So they're slightly different, and that difference can make this that connection fail. So you want to be sure that you're getting the right components, the right fittings for the type of drip that you're using. Now, what I do in the field, if I do see these two joined with the, say with the barbed fitting, right? I got somebody that thought that they were being real smart and knew exactly what they were doing, but this part failed, it popped off. So instead of going in and redoing everything, at times, I use these fittings right here. This is a universal fitting. Rainbird makes this one here. And you can join different size pipes together with a universal drip fitting. These come in really handy, of course, if you're in my line of work, or if you say you want to color coat things and you don't want brown tubing, blank brown tubing leading to your inline zone, you can do a black tubing leading there, so you really know that that's not drip line, that is drip line, and then you could join them with the universal fitting. That's something that I've done in the past. I don't do it anymore, but it's a great way to differentiate blank line from your dripper line. So that's kind of cool. And they can come in really handy. One thing here I wanted to show you is another component that comes in handy when you're using your cleanouts. So you got your cleanout here, and that's going to be in a little box. It's going to be in a little box, and you got this whole area mulched, right? Because mulch is great for water conservation. It protects the soil from erosion. It insulates the soil, so it keeps the temperature lower, and it also it prevents evaporation really from the soil too, because it's you have a nice layer there. But say you have all this landscaped and everything looks great, and you have your box there, but your thick layer of mulch, maybe somebody installed this box a little low and it got buried, and you're wondering where your cleanout is. You could actually install a little flag indicator, and what that does is when the zone pressurizes, the little flag comes up, and when it's not operating, it drops back down. So this you could put right up at your cleanout right there, right? So it pops up, and there's, you know, your cleanout's there. So when you're doing your maintenance, then these are pretty handy. This one here is a Netafim brand. It's really cheap, and I've had issues with them, but sometimes they work great. If you're doing smaller projects on your own, then I would say you could, you know, you could use these. But generally, your irrigation supply store is going to have 1 or 2 varieties of what they like to use. So there's another option for a flag indicator. It's going to be one of these little 0 pops. And what this does is you could connect this with your 1/4 inch line. So it looks more like a pop-up, right? And it is. And you could, but it's got drip components on it. So you put a 1/4 inch line, there we go, there we go. You connect it to a 1/4 inch line, and that plugs into your drip irrigation system. That can go just at your box as well, and that pops up. You just put a head on here that can be adjusted all the way down that doesn't spray, and it'll pop up and show you. So you use a yellow head so it's bright, you know. Couple different options. Actually, Rainbird makes the drip indicator, and it's a big yellow head, and it's pretty similar to this. So really, that's a good way to find your cleanouts. Another way is to actually make a map. So draw out your area and mark your components where things are. Not necessarily drawing where all the lines are, but a zone, you know. So let me see if we have anything else to go over component-wise. I think we're good on components. That's maybe a more detailed view of components, but I'm open to any questions now. If anybody has any questions about what we've talked about so far, how are we all doing out there?
Excellent. Thank you, Seth.
Yeah.
So, yeah, if anyone has any questions, put your hand up in the participants. And I do have one here. I'm going to unmute Naru.
What was that question?
I'm unmuting Naru so that
Gotcha.
okay, there we go. Naru?
Yes, can you hear me?
Yes, clearly.
Great.
Let me get a little closer.
Let me just go to my notes. I've been taking notes. Thank you first and foremost for doing this. I can see that our old system is totally outdated. I've been having so much trouble with this stuff. They've come out all the time and like, oh, this is horrible. So I wanted to know a couple of things. The first thing I wanted to know was, with this system, does it matter what time you water the plants? Because I know in the past when the water got on the plants, it was so hot, and it's like just recently, it's just been scorching everything. So is there a time you should water when you have a system like this? Should I ask everything at once or just stop there and let you answer?
I'll address that one really quick first. Okay. So as far as planting, you want to plant, you can plant any time of the year. Again, when you've got this hot weather, it's going to be hard to get a new plant that isn't going to be affected by the heat, because it essentially doesn't have enough root space to even support the foliage that it has without that pretty regular water. So, but once it gets in the ground, you know, a 2 to 3 day watering cycle is going to be plenty if you're watering enough. And you just want to keep an eye on them. Sometimes you can give them a little extra hand water from the top, you know, just to make sure that root ball is getting plenty of water.
No, Seth, I think you misunderstood. I'm talking about existing plants that I already have that are okay, mature. I just want to know about the time with this system. Like if I use the old system, if I water too late, it'll get hot. So just with this system, when it's underground, does it matter at all what time you water?
It doesn't matter at all what time you water.
Yeah.
So there's restrictions placed on spray heads at times because of wind and evaporation, but with the drip system, it doesn't affect that. So no, you could water throughout the day. And in fact, it's kind of better for a drip system, in my opinion, have it watering throughout the day, because then you can, let me just clear a text that I got. Because then you can clear, you can see if there's a break in the line, right? So if it's running the day and you happen to be home, like most of us are these days, you can see a big stream of water coming out if you have a broken piece of it. But doesn't matter what time at all. Yeah. And you have another question?
Yes, I did. I wanted to know, like, how expensive are these new systems, and what is the life of the inline tubing and check valve?
Yeah, so the material costs are a little bit more for sure because you have more material essentially. So let me just do an expanded example of this, right? So if you could imagine here, this is the point source again, kind of your old style. You go throughout the landscape with your tubing, and then you come off and you do this and you do that. So this is all pretty cheap. These are 1/4 inch, you know, that's 1/4 inch line. With this system, I've only shown you what 3 plants, right? So let's look at an example. If you have a very densely planted area, right? So let's just say here there's a bed and there's a lot of plants in it. Not really spaced out. It's going to be a nice full looking garden, drought tolerant. You know, medium water use doesn't really matter. If it's a dense planting, what we would be doing here is then putting rows of this, right, throughout the planting area. And this is giving you a good idea about how to lay it out too. If you're going to be doing this on your own, and then this all gets connected with like a header system. So all these are lateral lines. Those are the inline drip emitters. There's emitters everywhere, right? So that's a lot of material. So I don't have a percentage of how much more it costs, but I, you know, worked out, calculated. But I would say on material, you're probably looking at about 30 or 40% more in material. And if you're paying somebody to install it, you're looking at probably about the same amount more, maybe 20% more in labor costs, maybe 30% more. But the life expectancy, a well-maintained system like this, the inline system, you can keep that thing going 15, 20 years. There's really nothing that's going to break it down like the other type of system, right? As you know, like you said, you have an antiquated system and it's breaking here, breaking there. There's a lot of issues that go along with it. But if you have that nice thick layer of mulch over the top of this and you do regular system checks, so you're turning it on. If you have a little leak, that's okay. You fix it, you flush it, so any debris that maybe got in doesn't get in and clog emitters, and then you're back to operating normal again. So this can really stick around for the life of the system, which again, you can go 20 years or so with that. 15, 20 years is a pretty, 15 is on the shorter end of a zone or an irrigation system, and then 20 to 30 is going to be looking out towards the future. But I've seen these types of systems in the ground for years and years, and if they're maintained properly, or if you've just been really lucky and haven't had any issues with it being broken in any way, you know, like a shovel goes through it. So most of the time, it's a person who damages this. Pruners, when they're cutting and just going crazy, I know I get into this state of mind when I'm gardening and, you know, pruning sometimes where I'm very focused on the plants. And I mean, I've done that for years and I'm not doing that so much anymore. So I'm very careful because this is my focus now. So I know that I got to be aware of that. Or a shovel, you know, going through the tubing. That's primarily what I see the most is user error. The other issue that you may see are little critters, mice, squirrels, rats, chewing into the tubing to get to that water. So that's one of the downsides of having the check valve is that it stores the water in it. So you can do a couple things. You can just take your chances, which are really good. It's rare that they get attacked by animals. I've seen it happen a couple times, and it's not fun at all. It's not fun for anybody. If a squirrel, family starts to locate that water and go for it, you're out all the time fixing holes. But that's rare. That's very rare. A solution to that, if that does happen, is to actually bury that underground. So as this is, here's your ground. I mean, it's at soil grade, okay? So here's the soil and the tubing, where it's the same grade, right? If you're having that issue of rodent of some kind getting into and biting this, even though it's got a nice layer of mulch over the top of it, sometimes they can find that. The solution then with maintaining, with keeping this type of system is to bury it about 4 inches underneath the soil grade, sub-grade. And because of the check valve, you can do that. It's not going to suck up any debris into the emitters. Those point source, those small little emitters, they have a siphoning effect because they don't have a check valve. So, but again, very rare that rodents get down into it. But if they do, then you got to deal with it. Sometimes you'll see a bite here and there, and it's not a big issue. But for the most part, I have one installed in my front yard that I did 5 years ago. I've never had an issue with it whatsoever, And I just flush it every once in a while, twice a year, once a year, depending on how busy I am or how if I remember. So pretty stout, yeah, pretty stout.
Thank you so much. That was perfect.
Yeah, got it.
Thank you, Naru. All right, we had a few more questions, which I think you kind of answered. Have a 20-year-old system repair or replace?
That's a subjective as well. You may be able to use parts of it, but if it's a drip system and it's breaking down, then I would say replace it, because you have so much going on over that last 20 years. And without having, seeing this personally, I would say you probably have different components on it that shouldn't be on the, on the same zone. So going back to, let's go here. So what you'll see a lot of times too, oh, sorry, I got a maze in my living room here. What you'll see is a point source emitter system, right? You got these all over the yard, and then something wasn't working quite right. And instead of doing the research and maybe doing the right investigation into it, somebody just came along and they put a spray head on there, right? So now you have a very slow emitter that is how we want to do it for the most part. And you have this really high output going too. So maybe you added another 2 or 3 of these because, oh, well, that plant did great. But then what's happening is these emitters stop working because you're using too much of your water source through these. So we're going to actually talk about hydraulics in a little bit. And that's getting into how much water you can actually use for each zone. So yeah, if you see different components or different fittings on that zone, because that'll happen a lot of the time as well. Somebody will come in to fix it and they'll use the wrong fitting. And then, so yeah, I would say it may or may not need to be replaced after 20 years, but most likely if it's that old style of drip system, I would say you're pretty much, upgrade to the newer approach that saves water, that's easier to maintain. Another example is, another encouragement maybe, is these little fittings, right? This is the 1/4-inch tube coming off of that 1/2-inch poly to your point source. So these are really brittle. They become really brittle over time. Dogs, kids, deer, they get busted up, and then they get a little goof plug in here, and then that leaks a little bit of water. So they're just not very durable. So if you have had a system for 20 years that's like that, I'm sure there's a lot of issues. Now, if you install a system where you're not poking holes into everything because the emitters are right where they need to be, and you have the right fittings in place, there's probably nothing wrong with these unless they've been exposed to sun for 15 years. So Yeah, that would be the long answer.
We're at the hour mark. It's 5 o'clock. So should we stay on task and answer the rest of the questions at the end, or do you want to take a few more?
Yeah. If you see anything that is relates to the components and that type of thing, I'd be happy to answer another one. But yeah, we should probably get moving.
Yeah, I think one of that relates to the components is where people can purchase the components. And that, again, you might be able to give us a few resources that I can email to people too as well.
Yeah, absolutely. My number one referral for homeowners is the Urban Farmer Store. Okay. And they're in Richmond. And they are great. They are geared towards retail, not wholesale. So I do use them as a source for my materials. But they are a retail store, and they'll design a system for you, like literally draft it all out if you buy the components from them. And that's an expensive service. That I don't even offer it. I don't offer drafted designs, you know, because I want to keep my zone costs at a level to where people are thinking, okay, yeah, let's do that. So if you were, and I have referrals, I would, you know, just have them design it, or have Lori Palmquist, who is my mentor, irrigation mentor, design. If you needed that print, what I would do is draw out, you know, just a hydrozone map and put the components around. So yeah, the Urban Farmer Store is your number one residential resource, but you can always go to the other wholesalers. And the ones that I use mostly are going to be Ewing, EWING, and Water Savers is great, and Site One. Now those, and there's a few more of them as well. And up north, there's a different company, I forget the name, but if you look up irrigation wholesaler, you'll see who's in your area. Yeah, but they're geared towards contractors, so you may have to wait a little bit to get, you know, to get there. If you have a question, they might say, hey, can I get them out the door first, and then I can help you. So, but you'll get probably a little better price, but you'll get so much better attention from the urban farmer, and even a design, which could cost $1,000 for an irrigation design easily, $700, $800, $1,000. So I would refer the Urban Farmer Store for sure. So yeah, I'm going to keep moving. Does that sound good?
Sounds good. Yep.
So yeah, very important to know is your pressure that you're starting with. So here's a pressure gauge. You could take this. There's different ways to figure out where your pressure's at, and sometimes the hose bib from your house isn't going to be the same as outside. So, but my point is that you want to keep your pressure going into your irrigation system. You know, it'd be nice if it was 65 PSI or so. If you're going above 80, 90, then you're getting into high pressure. That's going to wear the components down. Going out of the valve into your filter and then your pressure reducer, this is for your drip system. So this, I like to have it 40 PSI. This one, I don't know if you can see, it's 25 PSI, which is fine. But I like that extra pressure just to ensure. So we've pretty much gone through a lot of the layout. Another thing that I wanted to just touch on were hydrozones. And I mentioned containers before, and I use that 1/4 inch inline to go into containers. The containers are their own hydrozone. So a hydrozone is just going to be plants with similar water use needs and sun exposure, that type of thing. So if you have full sun, low water plants in an area, that's a hydrozone. If you have a shady, maybe part sun area that has more medium water plants, then that's going to be a hydrozone. So you want to match your zoning up with your plant's water needs the best you can, because you're always going to be watering to that higher use plant in general. So if you have a high water use and a medium water use, then you could try to hit that middle spot with your watering. If you have a high water use and a low water use plant, that's going to be a lot harder to do. So just a little bit more attention to where everything is really important to have success with keeping things at bay as far as water use, keeping it down, you know. So another very important thing that we got to talk about is the soil-water relationship. So what we're going to get into now whoop, I'll be right back. I lost my marker. Okay. Okay, so we have soil and water. And remember when I was talking about that slowing the water down because the soil could then absorb the water better. So what we're really talking about is soil infiltration rates and irrigation application rates or precipitation rates, but we'll say either one of those. So soil absorbs water at a certain rate, and we choose how much water to apply. So we can design the application rate of the irrigation, but we can't change the soil structure essentially. Even by adding compost, you're still gonna have the same soil structure. So pretty basic. Infiltration rates. That's right, yeah. Okay, these are in inches per hour. So sandy soil, which generally you're going to be seeing as sand loam. The infiltration rate is 0.9 inches an hour. So it'll absorb water at a faster pace because it has a lot more pore space. It has more surface area for everything to grab onto. Loam soil, which is a really nice garden soil. That's that sweet spot that everybody wants for real. Is going to be a loam because it's really, really nutrient rich and there's a lot of air, there's a lot of good structure. That's 0.5 inches an hour. Clay is coming in at 0.2 inches an hour in most situations. And this is a simplified version. There's sandy loam, loam clay, you can have sand and clay, so that doesn't change much. If you have clay, you have clay. You get a clay loam. So these numbers change a little bit, but this is a really pretty basic way to look at it. So now we get to choose how to irrigate this because the soil is the soil. So what we want to do is match this as closely as possible. And I have some really quick numbers. If you have sand, and this is, again, we're talking about the inline emitter tubing, the 1/2-inch inline emitter tubing. If you have a sandy soil, you want to hit that precipitation rate wants to be close to 9, okay? So what we're going to do here is, yeah, everybody got these numbers. Sand 0.9, loam 0.5, clay 0.2, and that's in inches per hour. So with irrigation, I was taught to start on that lower level and match that number as closely as possible. That works most of the time. Sometimes, due to something in that soil structure, it's a little off. So I try to go above that number just a little bit. So one thing about this tubing, this is a 250-foot roll of the 1/2-inch inline emitter tubing. This one happens to be a 12-inch emitter spacing, so every 12 inches there's an emitter, and the emitter rate is 0.6 gallons an hour. So every single emitter is putting 0.6 gallons an hour out all the time. Pressure compensating, it's all even. So what they have here, they make this pretty darn easy for you. I'm going to bring this over to everybody. They have, where are we looking at this? Here we go. So right there, they have on their product the precipitation rates for how to lay this out. So if you lay it out in, if you use a 12-inch emitter spacing, and you have a 12-inch row spacing, right? So that's those rows that I was letting you know, a grid, right? Let's just do 3-4 lines, okay? So again, we're looking at this type of form, right? We have this out. Now, these are T's. So we just add that space, add another line, add another line. So really what we're talking about is in a grid form. Every 12 inches, there's an emitter throughout this whole setup. So if we have sandy soil, we want to go 12 by 12 by 12, and then a 0.6 gallon per hour emitter flow rate, and that's going to give you 0.9. Here, I'm going to do this 0.96. So again, we're a little over the sand. I'm going to do it this way though. Here we go. So for sand, we want 12-inch emitter spacing by a 12-inch row spacing. Those are emitters. That's the row. And at a 0.6 gallon per hour emitter flow rate, that's going to give us 0.96 inches an hour. So we're going to be covering our base with that. We're going to make sure that we're applying the water just slightly higher than the sand, the soil is going to want to take it up. So a loam is going to match. We're going to go 12 by 16 by 0.6. So a loam soil, 12-inch emitter spacing by a 16, yeah, there we go, 16-inch row spacing, and that is at 0.6 as well, gallons per hour. That's the emitter flow rate right here. That's going to give us 0.7. So now if we remember, if you look at your notes, we had the loam at 0.5 inches per hour for this soil infiltration rate. 0.7 is above that, yes, but it's not too much above it. So we're going to ensure that we have an even coverage. So for clay soil, we're looking at a wider spacing, and I go bigger. So I get the emitters. Oh, here. This is an example here. So this is 18-inch emitter spacing. What I showed you before was 12-inch emitter spacing, more or less right here. This is 18-inch. So what we see, we're spreading it out, which really means we're slowing it down. Again, we're really just slowing that water down. So in clay soil, 18 by 18, so an 18 emitter spacing and an 18-inch row spacing, again, at 0.6 gallons per hour is going to give you 0.43. And again, we're looking at the clay soil was 0.2. So again, just a little higher, but it ensures that you get that coverage. So emitters, you can take the time to offset these in the rows just by cutting them at a certain point. So you could start this one. Oh, there's your emitter. So you find where the emitter kind of offsets that. That's a technique. Perfectly fine. Legitimate way to go. I generally don't worry about that because the emitters are everywhere. Again, we go slightly above where the precipitation rate matches the soil infiltration rate. So we got water going everywhere. But you can make sure that each row is offset. And then when you go to install this row, you put the emitter right there, you know, make sure that it's there. So yeah, that's soil infiltration rates and correlating with how you would lay out the grids that we're doing here. So how about any questions now? That's a little bit of information. So anybody have any questions on the grid layout compared to the type of soil that we have?
Yeah, that's great. So if we could keep the questions right now to questions on clarification for this section, that would be wonderful. And if you could put your question in the chat, that'd be great too. I don't see any.
For that too, this is another little device. I was mentioning the pressure gauge. So if you see that your pressure is really high when it's coming into your irrigation system, into your valves, you know, before you get to your zones, then you want to do a pressure reducing valve. This is a plumbers install this for homes, but we install it for irrigation systems so that we don't have a high pressure ripping through these valves, because if you have that, it can damage the components. It wears it out more, you know. It's like walking compared to jogging. That's one way, you know. It's just more activity, more vigorous. So reducing the pressure, again, slowing the water down. We're really just trying to calm everything down, and then that'll get us to where we're at. So yeah, do we have any questions ready to go with clarification?
I think there's, how much does a 250-foot roll go for? I'm thinking they're talking about the 12-inch emitters.
Yeah.
About how much does that go for?
$60 to $80, depending on the brand.
And then in the chat, so the emitters are rated. We're talking 0.6 gallon water per hour. What volumes do other emitters release?
Yeah, so the typical flow rate for this type of system is going to be, and this is gallons per hour, is going to be 0.6 to 0.9. That's really what you're going to see. I didn't give an example of 0.9 in here. There is one example that I used 0.9 emitter flow rates, and it would be for veggie beds. So just pretend this is a veggie bed. Okay. And we have our grid in here, and this is a pretty close, we're going to go 12 and 12, if not even shorter than that, because that soil is really just full of, it's a lot of potting soils are very well drained, so you want a tight, close spacing. So if you get up to the 12 and 12 row emitter spacing and row spacing with 0.9, then where is that? I have that number right here. It's something like 1 point, it's 1 point something. Oh yeah, here, it's 1.4. If you go 12, 12, and 0.9, then you're going to be looking at 1.4 inches per hour for the application rate. So then it just comes down to programming. Now, the smaller emitters, your point source, these are going to be the same, you know, and these also go down to 0.2, 0.4. But in general, you're not going to use those lower flow rates because of the reasons why I was saying this has to be a little higher number. If you go too low of a flow, you might not get even coverage. You might be lacking in water somewhere. So I would recommend to go with the 0.6 or the 0.9. And then if you wanted to keep things, again, a little tighter, a little bit more insurance that you're going to get a nice even coverage, go with 12-inch emitter spacing, and then use your row spacing to get this number up or down. So 0.7 is a really good, medium, safe way to irrigate any zone, really. Even if it's clay, I would definitely go higher if it's clay, if it's established. But if it's you're establishing plants, it's all new planting, I would say 12 inches on 18 or 18 on 16. So you want to just find that balance. it's a quick calculation. The urban farmer can help you with that too. In fact, I have a little cheat sheet right here that you could find on the urban farmer's website. You download this and it has all these equations that will help you out as well. So if we have time, we'll go over one or two of these. But yeah, so the point source, you'll find going up to 5 gallons an hour on these little, well, they're bigger emitters at that point, but they're for agricultural purposes. But in general, you're going to find these point source at 0.5, 0.6 to 1 gallon an hour and 2 gallons an hour. But again, if you're putting water out at a higher rate, so 2 gallons an hour is twice as much as 1 gallon an hour, I wouldn't go more than 1 gallon an hour on these if you're going to be using point source. Yeah. So, pretty important to touch on a couple other things. Oh, here we go. Yeah, so for point source, if you're using, let me get this out of the way. I'm going to get this out of the way as well. So if you are using a point source emitter, and you have it at 0.6 gallons per hour, your precipitation rate, that number that we were looking at over in this column, is going to be fairly low. It's going to be about 0.36 inches per hour. If you go 0.9, it's going to be closer to 0.5 inches an hour. So something to consider right there. If you're doing a single point source, maybe higher is a little better because you're going to match that infiltration rate a little closer, unless you're in clay soil. Yeah, it's just one of those things. But if you're doing it this way, you're going to, again, have to allow that to spread out further. So you're going to have to run this for a lot longer or add more emitters if you're just point source irrigating. Now, and we're going to skim over this stuff because it's really more detailed, but it'll give you an idea of how to water properly. So we've gone over all the components. It's pretty straightforward. Now the scheduling, scheduling is tricky because what we're doing with irrigation is giving the plants, well, we're applying the water to the soil. So we got that taken care of. We know soil infiltration rate, precipitation rate. Now, with the precipitation rate, what we're really doing is we're trying to match that plant's water needs as well. So not only are we trying to get that volume of water at a slower rate to match the infiltration rate of the soil, we're trying to match the plant's water needs. And that changes all the time. We have heat, we have cool, we have wind, rain sometimes, shorter days, longer days, sun, shade. We have all these different components that go into how much a plant needs, how much water a plant needs. So scheduling isn't really as simple as turning it on in spring and then watering all year until fall and turning it off. It's really not. That's not conserving water in any way. So what we're trying to do, I'm going to do quarters or so here for a year, right? So what we're trying to do is in the winter months to the winter months, essentially. We're looking at January through December. We're trying to match the plant's water needs. So down here in December, or January rather, it's very low. The plants don't need much water. And then it grows and grows and grows until July in most cases, and then it comes back down again. So this is what all those numbers are for, right? This is really what we're looking at. What's this? How do we water that much right there? That's the peak water use. That's the middle of July. Now the shortened version is ETO. That's evapotranspiration rate. The O just means that it's for the landscaping industry. They use different numbers for agriculture. So ETO is evapotranspiration. And that is a whole other set of numbers that calculates how much water plants need. So what do we do in all of this space here, right? So normally you would turn your water on, say, in March. And some people are still doing this. They turn it on in March and they water all the same, and then they turn it off, and then maybe it turns back on or so here. But here we're not too worried about, right? It's not really watering most of the year. Here we're not worried about either. We want to water that much right there. But this space, all of this space, is where we could have water savings. We could save so much water if we're scheduling properly. One way to do it is to install a smart controller, Wi-Fi based, that does that for you. You program in the peak water use, and it does the water adjustments for you based on weather forecasted, but also actual weather. So it crunches all those numbers and adjusts the watering for you. This is beyond going to real efficient components. This is where you could really save some water. This is where a lot of conservation takes place. So again, lots of numbers here. Another resource, I'll get into a few more numbers. We can definitely talk about some of these numbers. Another resource, though, to learn more about ETO and to have a lot of resources at your fingertips is going to be puddlestompers.com. And this is Lori Palmquist, who I mentioned before. She's an irrigation designer, my irrigation mentor, and she is an educator as well. So she teaches all kinds of classes all over the place. Puddlestompers.com. And if you go to the websites of any of those companies that I mentioned before, or the manufacturers, if you go to Rainbird's website, if you go to Hunter's website, they're going to have all kinds of information, all kinds of calculations that you don't have to really worry about the formulas. You just plug in what you have, what you're doing, and they have all kinds of resources for you. So puddlestompers.com, and you know, Ewing has some good tools. I'm not sure about the other sites. The Urban Farmer has great resources on their website, as well as Hunter and Rainbird, I would say, would be a couple go-to manufacturers that have a lot of good resources on budgeting water and conservation and how to put all of this together. So let's take a look at, let's see here. Let's go for Benicia, okay? So the peak ETO for Benicia is going to be 6.4. That is, what this means is, oh here, I'm going to break this down one more way before we start this. The plant's water needs, like I was telling you about before, you got high water plants and then you have low water plants and everything in between. So a high water plant is going to get 0.9% of the ETO. That's how much water you're going to apply. A medium water plant is going to get 0.5 of the ETO, and a low water plant is going to get 0.3. So these are water use classifications. High water plants need more water. They're going to need essentially that number, but we do it with 0.9. You can call it 1 as well. So you could, we'll do this math real quick. A medium water plant in the peak season of July, it's going to need half of that number. These are inches. This is inches of water, essentially. So a low water plant is going to need 0.3% of the ETO. So in Benicia, in the month of July, the peak water use, the ETO for that month, that means the highest water need plants out there are going to need, just call it 6.5, 6.5 inches of precipitation. So with our numbers, we could figure out how to apply that. And so let's just take the high water use. We're just going to call it 1. We're just going to call this 1, and we're going to call that 6.5. So if our high water plants need 6.5 inches of rain or of precipitation in the month of July, and say we have loam soil, right? So we have, we're going to go 0.7. So we have 0.7 as our, oh, here, let me put it up here. 0.7 is our precipitation rate. 0.7 inches per hour. That's what our precipitation rate is if we're in loam soil, and we have the layout is then the 12-inch emitter spacing by 16-inch row spacing and 0.6 gallons per hour emitter rate. So from here, to get how long do we run it for? How long do we run our system to get 6.5 inches of water for a high water plant? So say a lawn, right? Just say, and you could sub-irrigate this stuff. You could do a lawn that way. But just as an example, we're going to take the water requirement, which is 6.5, and we're going to times that by 60, which is our conversion into minutes, and then we're going to divide that by our application rate. So I always use my phone for my calculator. I'm really sorry, I don't have that on me right now. If somebody can do this for me, sorry about that, I don't have a calculator. We got 6.5 times 60. And then you want to take that number, divide it by 0.7. Does anybody have an answer for me on that?
557.
Okay.
That sound right?
Yeah.
Yeah. Yeah.
557 or 67?
557.14.
Yeah. This is fun. We're getting into it now. So this total is 57. Okay. Now, this is the amount of minutes per month of July that we need to run our irrigation for to get that amount of water down. So what I do with this number, again, if somebody could help me out here, this is for the full month, the total minutes per month of July for a high water plant. So what we're gonna do is divide this number by 4, please, and give me that number, because that's how many weeks, right, are in the month. So we're gonna divide by how many?
It was the 557 divided by 4 was 139.
139. Okay. Now, this number for a high water plant in Benicia, we're going to run that 3 days a week to get a really consistent moisture down. So if you could divide 139 by 3, because we're going to take the weekly number and split that into 3 different run times.
46.
So we want to run our loam soil layout for a high water plant 46 minutes 3 times a week. And that's going to match. That's going to give us the very precise amount. That may need to change here and there. This isn't a complete science, but it does get you really close, really in that ballpark. So you may have to go to 50 minutes, or you might decide, you know what, let me see if I can get 40 minutes 3 times a week and see how everything does. So this is our starting point. 46 minutes 3 times a week. That's for a high water plant, okay? So let's use this number, which is our weekly number. I'm I'm gonna leave all this for now. So we have our 139. Now, if that is a medium water use plant, let's divide this in half, 0.5, 139 divided by 2, or 70, right? Essentially, we'll call it 70 because that's 140 just about, okay? So a medium water use cut in half, we're going to call that 70 minutes. And then that's divided by 2. The 70 minutes, we're going to split into 2 days a week, not 3, because it's a medium water use. They want a little more breathing time. They want a little less water. And then when you apply it for, you split that into 2, and that's 2 days. So again, divided by 2. So we're going to be 35 minutes times 2 days a week. So this gives you an idea of how to hit what the plants need as far as water-wise with a grid system, with this inline drip emitter system. So, and again, there's calculators online you can just plug your information into. This one from the Urban Farmer has inches per hour for your drip system. So you plug in the numbers there. Has application rate, runtime calculator. So it does essentially what we just did. And then it goes into sprinklers too. So, and then on the back side, they have more information on drip systems. You have maximum row length that you can go. So these are really important. This is my coffee spill this morning too, by the way. Sorry, it's not bright and clean. The other really important thing to consider when installing a drip system is going to be how many emitters can you install on one zone? How much of this tubing can you put down per zone? So, oh, you know what? So I just erased that. I wanted to the ETO and the bell curve that we were just looking at. I wanted to just kind of make sure everybody understands how important it is to adjust your watering from that peak schedule, because you can get 10% less in you know, moving up to May. You could have that running at 85-90%. I kind of go June, July, August 100%, and July a little more because of our hot snaps that we tend to get around here. So I do my scheduling that way. And again, you find your own way in your own garden. Every situation's a little different, and that's the truth. So you got to kind of tweak things here and there. But you want to try to reduce the watering. Here's the peak in July. You want to try to get that down 10% down, 20-30% down, so you start to use less water throughout the year. And that, if you follow that bell curve as far as how you're watering, you can really reduce 20% in your water bill pretty much for the year. And if you move to these components and you go to the controllers and that type of thing, and you do regular maintenance, you can really get your water use down in the landscape. So that's pretty important. So moving on, I'm not going to take questions on this because it's pretty detailed, and there's a lot of resources out there that I mentioned already. So if you want those resources, again, we could talk about that at the end here. But I wanted to talk about hydraulic limitations, because that's going to make or break a system. When I say hydraulic limitations, I'm really talking about pipe size. So this is 1/2-inch tubing. If you're going off of just the size of this pipe, which is a good way to build a drip zone, that's nothing wrong with that. It keeps it really simple. So say you come out of your valve, and you can see at the bottom here, I have my conversion from PVC 3/4 inch to this elbow that has a barbed fitting for my tubing. So I plug this in, I plug blank line in here, and run that to my zone. Then I switch out into the inline emitter stuff. So if I'm using 1/2 inch blank line to get to my zone, I have only, so this is pipe size. Pipe size, 1 or 1/2 inch. You have 4 gallons per minute. So if you're using 1/2 inch pipe or tubing, you have a limit of 4 gallons per minute that you could run through that. If you're using 3/4 inch, oops. There we go. So if you're using 3/4 inch, you have 7 gallons per minute that you could run through a 3/4 inch pipe, which is what this valve is coming from. So if you have 1 inch, you have 12 gallons per minute. Again, let's make it simple. Try to stick within this per zone, 4 gallons per minute, and then you're going to be safe. Then you don't have to worry about it. Now, in the case that you have a bigger zone and you don't want to install a new valve, a second valve, you can, they actually, I don't know if I have any on me right now. 1 second, let me show you the trick and the tool. Okay, not on me right now, but they have adapters like this one, but they split into 2. So you have the 3/4 inch feeding 2 1/2 inch lines, which you could then go off of the hydraulic limitations of the 3/4 inch if this splits into 2. You can also take a 3/4 inch PVC pipe or poly tubing to your zone, as long as you have a couple different connection points. Let me go over this really quick, because it can save some time and money, and it can make a bigger space that is one zone, just one zone. So I'm going to erase this. I'll give everybody just 1 quick second here to take that in, write it down. And pipe size. I can give those again if we missed it, if anybody missed it. But just say you have a 3/4 inch pipe, you have a bigger zone over here, and you have your valve and all your great components, okay? And this is 3/4 inch line, and you do want that capacity. You do want 7 gallons a minute. You want to run your 1/4 or your 3/4 inch line to your zone. Here's our nice big zone, okay? And we have all those lines going through it. I'm not going to draw them all out, but you get that, right? So lots of tubing going down. Now, you can't just, okay, there's all the connections there. So we have this full of lines, right? There's tubing everywhere. You can't just take this and hook it to here and call that good, because then you're going to be going to just 1/2 inch. And if you're in this grid form and you're tapping in at just 1 point from the 3/4 inch, then you're going to be still limited to your 1/2 inch. So a great thing to do would be to connect this at 2 to 3 different spots, so that you have all this available water coming in at different points. That way you're actually overdoing it, which is good. I don't mind overdoing it. But at least 2 connection points, and then you're going to be set. You're going to be just fine. Again, a little more detailed. If you're doing this yourself and want a consultation, you could get in touch with me, call the urban farmer, call one of the other resources, and get those numbers. But just to give you a good idea of how you can build small, big or small. So along these lines, what we're going to do now is just take a look at the max amount of tubing that you could use for these areas, right? So, and I'm going to base this off of the 1/2 inch tubing So if you're going from the valve to the 1/2-inch poly that feeds your zone, this is in a grid form like that. This is the amount of tubing that you could use in this zone. And again, we're looking at 4 gallons per minute, okay? So if you have the clay soil and you are using that bigger spacing, the 18-inch emitter spacing and the 18-inch row spacing, you're going to be able to put down, I'm going to do this here. So 18-inch by 18-inch, and this is 0.6 gallons per hour is the emitter rate. Then you can put down 600 feet of this tubing. 600 feet if you're going off of this hydraulic limitation. So that's a decent amount of space. And again, if we double that, because your row spacing is 18 inches, so if we add 50% to that, because your row spacing, to get a square footage, you could do 900 square feet. That's a pretty big zone with 600 feet of this tubing in this layout. Now, if you got emitter spacing, let's see, we got 12-inch, but essentially when it comes down to it, we're looking at an 18-inch emitter spacing at 0.6 gallons will give you that much tubing. That's how much tubing you can do. So this gives us how much square footage we can do, which we're not really going to go into either. 0.6, yeah, 0.6. So if you're using the emitter spacing, that's 12 inches, right? So every 12 inches, you have an emitter. Not every 18, but every 12, and it's 0.6 gallons per minute. And we have 400 feet of tubing you could put down. So if you're in a sandy soil and you're putting this stuff down, and it's 12 by 12, then you have 400 square feet that you could do, because that's essentially 12 by 12. You're looking at square footage. If you have a greater amount of that, if you have, say, 12-inch spacing, emitter spacing with 16-inch row spacing, if you do the math on that, you're probably looking at about 550 square feet or so that you could do with this tubing, with the tubing that's every emitters are 12 inches apart and the flow rate is 0.6. Now, if you're in that veggie bed situation where you have a higher flow rate and you're doing these, you know, pretty closely spaced, so it's still 12-inch emitter spacing, and you got the 0.9 gallons per minute tubing, you could only go 250 feet of tubing if you're using this combination. So again, if you're 12 by 12, then you have 250 feet, square feet you could irrigate with this. If you have a very high infiltration rate, then that's how much tubing you could use. That pretty much covers everything in a somewhat detailed but pretty basic way. That's really what we're looking at when we're doing irrigation. So I'm open to any and all questions at this point. I've said all I have to say.
Thank you, Seth.
Yeah.
So I'm going to put our survey in. So everybody, please, if you can, take this survey. It helps it to just guide us into like what classes we bring to you all. So it really helps. So one question is, how do you get the feet of tubing? How do you get
Right. So they sell them in rolls. This one is a 250-foot roll. They do sell 100-foot rolls as well. And they're a little easier to manage. This is a little heavy. One person can deal with this. I get the 250 because they're not too heavy and it's a decent amount of tubing. If you're using the 250-foot roll of the 12-inch emitter spacing with 0.9 emitter rate, gallons per minute. I'm sorry, that's gallons per hour. Sorry about that. Gallons per hour on the emitter rate. then this is as much as you could use. You could only use 250 feet of this. So that makes it really easy for you. If you are getting into these numbers, then you could split it up and just buy 100-foot rolls. Or again, I always go with 250-foot rolls. So if we were using this configuration, again, that's not minutes. Sorry about that. These are all gallons per hour. Those are emitter flow rates, gallons per hour. This is actually, that's right, 4 gallons per minute. You can go through there. So, and I did all this calculation here already. So that shows that that is your max. 4 gallons per minute is 650 feet of that configuration, the 12-inch at 0.6 gallons an hour. So yeah, 250-foot rolls, 100-foot rolls, they go 1,000-foot rolls. There's no need for anybody to homeowner, residential stuff doing it that need anything more than a 250-foot roll.
And can this system be used for trees as well?
Yeah, absolutely. A popular method for doing trees are rings. And so instead of that grid form, because trees are really spread out usually, right? So let me get my plant marker. We have our trees, beautiful big, I don't know, valley oaks that are going to be established, and just you won't have to water them after a couple years, 2-3 years, Still want to get the irrigation system in. So this is, again, their full, this is their mature size, right? So what you would want to do, here's the trunk. What I'm going to do is I'm going to go in and erase one of these. Just pretend these are all the same size canopy. But as a new plant, they're only this big, right? They're just like this. Here's a little tree, but their mature size is going to be here. So what we want to do, again, without doing a point source, right? Without putting that water right on the root ball, we want to spread that water out, way out, so that the tree's roots grow into that moisture. We're giving them a better opportunity to become established and stand on their own if we water properly in the beginning. So if we water deeply and a little bit less frequently for trees, then they're going to become established. So and then we could get them off of the water. So again, we're looking 2-3 years down the road. How much water can we save in the future too? So we really want to think about all of that. Here's the trunk. That's going to get it established. That's going to get the tree going. But what we do is we put another ring, say 18 inches away, and then another one 18 inches away as well. And then the water source is coming in. So this is the tricky part. What we want to do, and if you remember when I showed you that one example here where we had the flush, we want to keep the water moving in one direction. We don't want little eddies. We want to make sure that the whole system is moving and it is able to flush at one point. So you get these, and then we'll replicate that. We know what's happening there. So our water source is coming in. We want to go to the very center, okay, and start our watering here. And then if we go here, that comes out, and then it comes out. So what I'm going to do is I'm going to come in underneath all this tubing with my blank line. I'm going to connect to the inner circle. I'm going to go out of the inner circle to this ring, okay? So the water flows to this side, it goes out, and it flows out this way, and then we connect this ring to the outer circle, and then that water flows out to this ring, and then we're in the right direction, we're moving. So we do the exact same thing. We go here, in, we go out to the middle, out to the outer, the water flows through, and then we take that to the next one. So, and then here, just say there's 20 feet right here, right? So we don't water in between here. There might be some plants, however. This might be a little planting zone. So that would be another zone. We do blank line, bring that here, do our tubing, do our thing. okay? And you're always trying to find that flush point. So here we have this kind of a point that's going downward. We always want to balance that, where the water comes in and where it comes out. So here, I wouldn't perfectly center it. I would probably take it in just to the offset so it drains out that way. So we have the water flowing through everything. So there's our little clean out. And then, you know, we have another zone over here that's a bigger zone, but it's more spread out. Maybe there's a big hedge over here and then some smaller plants here, but it's kind of spread out. So we bring our line in, and then here maybe we choose just to water these with 2 because there's a little more space between everything, and then we come off here and water just these 2 with those lines. Okay. Oops. Stop that. Reverse. Go here. But we want clean out still, right? So this is where that one stops. So here, we don't continue the lines if there's no plants. We do a blank line to meet up with that blank line, and then here's our clean out. There's our box. So you see, we always want the water flowing. And here there's a big boulder, so we don't want to, you know, in a dry stream bed even, right? We got a dry stream bed coming through here. So you can see this stuff is very adaptable to the situation that you're in. You can really do whatever you want with it. And it's just a matter of a little bit of planning. And you can get professionals to help, or you can do all the work with those resources that I gave you too. And it can be fun for some people. It can be a lot of fun for some people. I like it. Any more questions? What else do we got out there?
Oh, so we have, how do I find out the incoming water pressure to my house?
Yeah, so that can be tricky. I was touching on this earlier. This is a gauge, again, and if your water is separated, the house is separated from the outdoor water, which is ideal. You got to find a source pre-house, because sometimes the houses have this, you know, pressure reducer on them, but the water source for your irrigation is coming off before this, and this might be at 110 psi, the main line coming in, but then they reduce it to the house, and here you got 70 or so, 65. So if your water source is pressure reducer for the house, or if you have one of these, you could find a hose bib maybe that isn't on the house, that isn't after the house coming out of the back of the house, but in the yard somewhere. So take a pressure reading of a hose bib off the house, and then maybe one out in the yard, like in the front yard or whoever, whatever your situation is. It can be a little tricky though. One thing that I didn't show you was a shutoff valve, and this is to isolate the water. A lot of times you'll have this for the house as well, right? You want to be able to shut the water off to the house. You have your water meter, and then you have isolation valves. So ideally, your irrigation water is coming off before. Here's your street, here's your meter, right? Your water meter. And your house, okay? And then the main line comes in, connects to the house. You have a pressure reducing valve coming in here, so you got 65 psi for the house, and then you have a couple of hose bibs. And those are all gonna be about 65 psi. Now, ideally what would happen is you come off here for your irrigation water, okay? And that supplies the valves throughout the yard. You know, maybe you have 6 valves. So one thing you could do is call your water provider, and they'll give you a static pressure from a hydrant close by. You used to be able to call the fire department, but what we've been doing lately is just calling your water provider and saying, hey, this is my address. Can you give me a static pressure? What's my pressure coming in? And that's going to be pretty close. If you can't do that and you do have this water source available, then what you might want to do is dig a portion of that main line up and cut it, put a T in here, and then with an adapter, you could do a little pressure gauge on that, or just cut that, cap it, and make the adapter so you can put a pressure gauge there. That you don't necessarily have to do that, but sometimes you gotta find the pressure, and that's one way to do it. Another way to do it is to install your valves. Okay, check this out. If you got a drip system going in, right, and you don't know your water pressure yet, but you know that you can fix it because you have a main line coming in, you've already tapped into it with the valves. You got 3 or 4 of these in a line. Now, right here, your blank line is going to be coming off. Cap that. What I do in this situation is that figure 8 that I showed you earlier. So you have no flow coming out of here. You turn the valve on, and your filter has this cap to flush it, right? That can flush the inside of the filter. But you can also put on a pressure gauge. So you do this. You have this blocked off where the water is gonna flow to your zone. You have that capped, and then you got your, and then you turn the water on, and then you have a static pressure reading of the main line. Essentially, you have a little bit of drop here, but very little, very little. So that will give you your main line pressure. There's static pressure and there's dynamic pressure. So once you connect your zone and have it all working and you flushed it, you can still do this and get a dynamic pressure reading, which is really important for irrigation systems. You want to know, or you know, it's a good piece of information to know your static pressure and your dynamic pressure. And this tubing that I'm showing you needs to have 15 PSI to operate, to fire. So if you have an issue with your system and you throw this on and you see that it's at 12 PSI, because you don't see you know, some emitters aren't working, then you know that you have an issue. You know your pressure isn't enough. So you know there's something going on. It's just another piece of information. Hopefully that helps.
Thank you, Seth.
Yeah.
It looks like it is 6 o'clock, and out of respect for everybody's time, I want to stick to that. But I did have to share one more question because I thought it was funny. How deep do I bury the tubing for snow?
Yeah. Honestly, I don't know. What I would do in snow situations is you want to drain your system. Essentially, you want to winterize it. So you want to flush it. You want to open those valves up at the end, those clean out valves, so there's room to move. And you want to shut your system down with the shutoff. You always want to have, so say you have 3 or 4 of these in a line, you want to shut that off. You want to shut off so that the water still stays onto the house, but you could shut off the manifolds. So you would shut this off, but then open your valves, open the flush valve, maybe even get some air going through this to clear out the water. But if you are burying it, it depends on your frost layer. You know, how deep does that frost go? So how much frozen ground do you get, essentially? If maybe you're talking about Tahoe, or maybe you're out, you know, in Colorado. Who knows? We have a lot of people with us today. You would really have to look at that frost layer, and you could bury this stuff 6 inches deep under the ground. It takes a lot more time to do that, obviously, than just putting it on the soil surface. But if you're really concerned about efficiency and you want to use the system, then I would just look at how deep does your ground freeze? But it's flexible, so it doesn't shatter. And if you have things opened up, there's that room for, you know, the water to expand and do its thing. That's the best I can give you on that one. But I would say, 4 to 6 inches, depending on. But if your ground is freezing a foot, then I wouldn't know, honestly.
Well, thank you so much, Seth. And if, like, maybe you could send me an email with any further resources that I could send out to everybody that registered, so they can continue their research on drip irrigation. So I'll send that out to everybody.
Absolutely.
And so you can continue your research, and then definitely with your contact information. And oh, you're going to put it up right now?
Yeah, I'll just put it here.
Okay, excellent. This
well,
is
yeah.
I think your information's in here. We.
What's that?
we put a link to your information. You're on our website, so we'll take care of that. But if there's any other like websites or anything that you could send me, I will send a link to everybody so they can further their research. And thank you so much for helping us with this. It was a great workshop.
Absolutely. Thank you everybody that showed up. Thank you Sustainable Solano, and just keep up the good work, everybody. I know there's so much going on right now, and I just like, for me, I think following your passion, whatever it is the key to getting through all of this, you know, and sustainability in general. And just like, if you find something that grabs you with, you know, ecology and sustainability and just treating people well, like just go for it. Because I think this is the type of change that we need, is looking out, we're stewards of the land that we're living on and the communities that we're involved in. So I really appreciate everybody showing up and to have this opportunity to share my knowledge with you on irrigation. Thank you very much.